A warm welcome to one and all. This is Preethi, Assistant Professor, Department of ECE, Dr. NGP Institute of Technology. Now I would like to share my knowledge on directional couplers. Before going on to directional couplers, we should know the purpose and the meaning behind the power division and power combining. So in microwave components, consider P1, a power, is given to a divider. It gets divided into two different powers, P2 and P3, that where P2 is equal to alpha into P1 and P3 is equal to 1 minus alpha into P1, where alpha is a directional constant. Then coming on to power combining, we give two different powers, P2 and P3, to a coupler, where the coupler adds or sums or couples the two different powers and gives you a single power P1 that is equal to P2 plus P3. Now coming on to power dividers and couplers. The power dividers and couplers are passive microwave components used in many different applications, mainly for power division and power combining. There are both 3-port and 4-port components. Some are listed below. There is T-junctions, for example, E-plane T and H-plane T, hybrids and directional couplers, quadrature and magic T-junctions, resistive power dividers, and Wilkinson power dividers. Now coming on to a differentiation or comparison between a directional coupler and a quadrature hybrid coupler. Both are 4-port networks or 4-port network components. The amplitude response, the phase response, and the isolation written laws of both the components are different in their own aspects. But when comparing, directional coupler gives you a better performance characteristics compared to hybrid coupler. Coming on to directional coupler. It's a passive device that divides and distributes the power. It is a built-in waveguide assemblies which can sample a small amount of microwave power for measurement purposes. It is used in true transmission lines close enough each such that the energy passing through one is coupled to the other. Coming on to the device ports. There are 4 different ports. One is input port, transmitted port, isolated port, and a coupled port. The transmitted port could be called as through port also. We could see 2 different directional couplers. One is 4-port directional coupler, another one is 3-port directional coupler. Now consider a wave traveling in the upper waveguide from port 1 towards port 2. At each hole, a small portion of directional coupler is transmitted into the second waveguide, generating 2 waves traveling in opposite direction, one in the forward direction and other in the backward direction. Since the electrical distance between the 2 poles is considered 2, the 2 forward waves add in phase at port 4, while the backward waves are 180 degree out of phase and this cancel at port 3. This is how the different ports, that is input port, transmitted port, isolated port, and the coupled port works. Now coming on to forward coupling. Forward coupling is nothing but when you give input in port 1, what could be the output? That is, a portion of power traveling from port 1 to port 2 is always coupled in port 4 but not to port 3. As I said, in port 4, both the waves, both the divided wave and everything will have a same phase such that it gets added up. But in port 3, they are out of phase with each other where it gets cancelled. Now coming on to backward coupling. Backward coupling is nothing but a reverse coupler where the energy that propagates down the transmission line starts a reverse wave down transmission line. They are always backward wave couplers. Figures of merit. Directional couplers always depends on 3 different measures. One is coupling factor, directivity, and isolation factors. These 3 factors will define the performance of a particular directional coupler. First one, coupling factor. It indicates the fraction of input power that is coupled to the output port. It is also the ratio of incident power to the forward power measured in dB. You could see that C31 is equal to 10 log P3 by P1. Coupling is always not a constant. It varies with frequency. As the frequency increases, the coupling factor also will increase. The coupling factor is nothing but it is specified in terms of coupling accuracy, and the accuracy is high whenever the frequency is also high and it is also frequency sensitive. The larger the frequency sensitive, will allow a larger frequency band of operation. Now comes the isolation factor, defined as the difference in signal levels in dB between the input port and the isolated port when the two other ports are terminated by matched loads. It is defined to describe the directive properties of a directional coupler, also defined as ratio of incident power to the back power. Isolation in dB is equal to the coupling factor plus directivity. Now comes the directivity. Directivity of a directional coupler is defined as the ratio of a forward power to the backward power. The coupling factor is a measure of how much the incident power is being sampled, but while the directivity is a measure of how well the directional coupler distinguishes between the forward and reverse traveling waves. Directivity always should be as high as possible. As we discussed, directivity is equal to isolation minus coupling. Directivity is very high at design frequency and more sensitive function of frequency because it depends on the cancellation of two wave components. Here you could see the depiction of directional coupler, where directional coupler is nothing but isolation is equal to coupling plus directivity, and the bidirectional property states that whenever we give input at port 1, the through port, the coupled and isolation port, how it reacts and what could be the output. Next is losses in the directional coupler. The directional coupler consists of three main losses: mainline loss, coupling loss, and insertion loss. Mainline loss, it indicates the power loss as the signal travels from the input port to the through port. Ratio of the input power through the input port to the power output of the through port. Next is the coupling loss. Coupling loss indicates the portion of mainline loss that is due to coupling of some input power into the coupling port. This loss is unavoidable. That is conservation of energy. Due to conservation of energy, this loss is always unavoidable. Next comes the insertion loss. Insertion loss is nothing but, ideally, when we consider two different powers, P1 and P3, or port 1 and port 3, that is equal to port 2, it gives the coupling loss or the mainline loss. Practically, couplers are not perfectly lossless. The additional losses due to the absorbed energy, that is heat, is always there in the directional couplers. It indicates the portion of main loss that is not due to the coupling in the ports. This is avoidable and it could be corrected by some measures. Next comes the coupling insertion loss that could be measured using a real-time scenario. You could see the main arm loss which is being compared with the coupling factor. Directional coupler has many applications. The first one is monitoring or power measurement. The coupled output from the directional coupler can be used to monitor frequency and power level on the signal without interrupting the main power flow in the system. The next main application is frequency measurements, where the signal leveling could be done, reflection coefficient measurements could be done with the same setup just by using a directional coupler with a frequency inline measurements, that is signal sampling, signal injection, and VSWR measurements. Next is making use of isolation. The isolated port has its own use, that if isolation is high, directional couplers are good for combining signals to feed into a single line to a receiver. Coming on to overview, it gives the comparison of different dividers and combiners along with the directional coupler. Here we compare resistive power divider, Wilkinson power divider, directional coupler, and quadrature hybrid. You could see the various uses of particular devices and the phase shifts which are available in the devices, because initially the resistive power divider or Wilkinson's power divider doesn't have any phase shift, they're in phase, but the directional coupler and the quadrature hybrid dividers are having 90-degree phase shift, and the practical bandwidth ratios also differ from one to the other. I hope the session would be useful for you all, and thank you for your patient hearing. Thank you.